The topic of this video is graphing piecewise defined functions. All right, let's look at this problem. h of x equals 3 if -4 is less than x is less than -1. Absolute value of x if -1 is less than or equal to x is less than or equal to 4. And square root of x if 4 is less than x is less than or equal to 16. So we notice that in this particular piecewise defined function, all three of our domain restricted functions come from the library of functions, proving once again how very, very important it is to know all of your library of functions. All right, let's go ahead and move through the steps. So the first thing we look for is equalities after if, right? Something of the form x equals number. And sadly, we don't have any of those here, which means we're going to need to make 3 complete graphs that we will cut and then keep only the relevant pieces and then put our open and closed dots. And then we will merge all of those together into one final picture. All right, let's begin. Here we go. Let's start with the first one. h of x equals 3. Well, that's the constant function. The input x goes into a machine named h, and no matter what x is, what comes out is 3. So I can just write 3, 3, 3, 3, 3 for all the y's. And the x's, well, I'm going to be smart about this. Normally, I would just do -2 to 2 with my x's, but I'm only going to use this particular function if the x's are between -4 and -1. So let's do this. Let's do -5, -4, -3, -2, -1, and what the heck, we'll throw 0 in there as well. All right, so let's plot these points. So -5, 3 would be here. -4, 3 would be here. -3, 3, -2, 3, -1, 3, 0, 3. Obviously, these are making a horizontal straight line. Lines, line segments, and rays must be drawn with a straight edge. So use your straight edge and connect all of these dots together. Since this is a line, I'll put arrows at both ends of it. Okay, there we go. We have now created our entire graph for h of x equals 3. Now we have to cut it. So we look after the word if, and anywhere we see a number, that is a place where we are going to have to cut. So -4 is a place where we have to cut, and -1 is a place where we have to cut. So find the point with an x of -4 and cut there vertically. Find the point with an x of -1 and cut there vertically. And then decide what part to keep. Well, the x is in between the -4 and the -1, so we keep the part of the blue line that is in between the two cut lines. All right, so now we can see that instead of having a line, we have a line segment. Okay, and now the final piece for this particular graph is the open and closed dots where the curve meets the cut. So at -4, we have an open dot where the blue curve meets the red cut. So an open dot at coordinates -4, 3. And looking here, at -1, we have an open dot where the blue curve meets the red cut. And so this is also an open dot, and the location of that open dot is -1, 3. All right, 1 down, 2 to go. Let's move on to our next one. All right, for our next one, we're dealing with the absolute value of x. h of x equals the absolute value of x. So we have to know our absolute value coordinates very, very well. Now, traditionally, we would do -2, -1, 0, 1, and 2. But in this particular instance, we might want to expand our horizons just a little bit, knowing that x needs to go all the way out to 4. So let's try something here. Let's do something we haven't done a whole lot of, and let's just go a little bit further with our table and see what happens. All right, so the absolute value of -2 is +2. The absolute value of -1 is +1. And the absolute value of 0 or a positive value is the same value. So I just get all of these numbers repeated right on down the line. Okay, now we just have to plot them. So -2, 2 would be here. My table of values is somewhat in the way of my graph. -1, 1 would be here. 0, 0, 1, 1, 2, 2, 3, 3, 4, we're getting that nice V shape that we're used to getting whenever we play with absolute value graphs. So let's go ahead and connect these dots with a straight edge. Absolute value is consisting of two rays. There's the first ray right there, and there's the second ray right there. Lines, line segments, and rays are always drawn with a straight edge, so make sure you're using a straight edge when you're creating this graph. Okay, now we have to figure out where to cut it. So we look after the word if for any numbers. We see -1 and +4. So -1 is right here, +4 is right here. So find the point in the graph with an x of -1 and cut through it vertically. Find the point on the graph with an x of 4 and cut through it vertically. X is in between -1 and +4, so the part of the graph that we want to keep will be in between the red cut lines. So then our graph looks like that. As you can see, I've really made a mess of my table here. This got very messy. I apologize for how messy this is over here. Let me see if I can put this back a little bit. All right, and now we have to put open and closed dots where the curve meets the cut. So we have a -1 is a closed dot where the blue curve meets the red cut. So we get a closed dot here at location -1, 1. And over here, we see that we have a closed dot at 4 where the curve meets the cut. And so that would be at this location, which is at coordinates 4, 4. All right, 2 down, 1 to go. Let's move on to our third piece. Our third piece is the square root function, and it's my hope that by the time you've reached this video, you have already practiced these so many times that you know all of these numbers instantaneously from memory. That is my expectation. And let's plot these points. So here we go. We've got 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. And when we connect these together, we get the kind of shape that you might see if you took a parabola that opens up and rotated it 90 degrees to its side and then just kept the top half. All right, that is our square root function. Where do we cut it? Well, after if, I see 4 and 16. So 4 and 16 is where we're going to cut it. So right here at 4 and right here at 16. So find the point with an x coordinate of 4 and cut vertically through it. Find the point with an x coordinate of 16 and cut vertically through it. And because x is in between 4 and 16, we keep the part of the graph in between the red dashed lines. Okay, so there's that. Now we just have to decide what kind of dots we put where the curve meets the cut. Well, when we look at the value after the if condition, 4 is next to a less than symbol, so that's an open dot at 4 where the blue curve meets the red cut. So that would be an open dot at coordinates 4, 2. And the 16 is next to a less than or equal to symbol. That creates a closed dot where the blue curve meets the red cut. So we get a closed dot here at coordinates 16, 4. All right, whew, we made it. We did it. All 3 pieces have been created. Now all we have to do is put them together. So we have to take this little blue line segment and this little blue check mark and this little curvy line segment here, curvy segment, I guess I wouldn't call it a line segment if it's curvy, this little curvy segment, and put them all together on the same picture to create our final product for this particular problem. All right, so here we go. So we need an open dot at -4, 3, that would be here, and an open dot at -1, 3, which is here, connected by a straight line segment. So once again, I'm going to get out my straight edge. This is a little high. Let me lower that just a smidge. And connect those. Okay, then I'm going to put a closed dot at -1, 1, which would be here. I've got a dot at the origin. And I've got a closed dot at 4, 4. And I'm going to connect those together with my straight edge. That line segment And that line segment should be constructed using a straight edge. Okay, and then finally we have an open dot at 4, 2, a closed dot at 9, 3, and a closed dot at 16, 4, and a curve that's connecting them all together. This is curved. I know it may not look like it's curved, but this is curved, so do not use a straight edge for this part of the graph. This is the part of the parabola that we decided to keep. Okay, and I believe that is it for creating the graph. So as you can see, these problems are on the longer side, and they are made all the longer if you do not know your library of functions so very, 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 very well. So make sure by the time you get to the end of this material, you have thoroughly investigated those library of functions and know them from memory almost instantaneously.